Hello everyone and very good evening. Once again, welcome back to the session. So the other day we were discussing about various algorithms and steps to solve any business problem, etc. And today we want to understand one such algorithm, which is a classifier, which is nothing but a supervised learning algorithm. Okay. So the point here is when we are trying to work with supervised learning algorithm, it is supervised. You have regressors and classifiers. Okay, regressors and classifiers. So what is it which is important here is regressors means when your prediction is a numeric prediction. Classifier is when your prediction is categorical. And mostly if it is a binary scenario. So here when we're talking about classification models, generally when the supervised learning algorithm, the name itself is supervised. So when it is supervised, you have to supervise it while learning is happening. While you are learning it, while you are given training, you have to supervise it. So here when you are supervising it, definitely we look for accuracy because supervised learning algorithm is applied when your y is known to you. When your y is known to you. Suppose you are working, you want to know that for any movie, like what is this movie can win an Oscar or not. Whether a person, if an ad campaign is running, whether a person would have purchased that particular product or not. If at all you are using a Facebook ad, whether a product is getting purchased, what is the amount of time spent on it? Right? So depending upon the different inputs you take, products purchased or not, he liked or disliked the product, the review is a positive or negative review, right? Whether what is the television advertisement rating, what is the rating given to newspaper, right? So depending upon the type of input you have, y is always a classifier, it could be 1 and 0. So one of the applications here is in predicting the television, what we can say is advertisement rating here. So when it is a television advertisement rating here, television is the most effective marketing media, and also most of the advertisers today prefer even television. One such parameter is that you measure the success of a television, the rating of the programs on the television. So it is also that the consideration of the advertisers in choosing a television station. For many organizations engaged in advertising industry, especially people like customers being from different levels of living, right? There are few places where people opt watching television rather than social media. So historical data is related to the ratings that have been obtained. So companies are able to provide rating predictions with a normal version period. So the approach here they have done is a KNN algorithm. So to classify your advertisement ratings, and people they have compared three different, whether it is television, newspaper, whether it is your WhatsApp, like you are just posting it, or you should not use WhatsApp, it does YouTube ads, right, on LinkedIn. Based on this, the time spent and the amount spent, right, how many people are getting attracted and they're purchasing the products. Right? So the results can provide us options for the advertisement companies so that they can evaluate things easily and understand which media is being preferred the most, right? Which is preferred the most. And something like KNN is one of the classifiers. It is nothing but nearest to neighbour. If two customers are there, he is near to him or he is near to the other customer. Right? So in order to make particular decision making process of the consumers, and in order to take the price and the purchase intention of any product, right? That he have purchased a product and how likely he is to purchase this particular product. If the distance between these two are less, if the distance is less, means if they have these two are similar people, similar kind of purchasing behavior is what they feel, right? So here this algorithm is used to optimize things, pricing strategies and promotion strategies, which will help us for a better product sales here. So future precision marketing process, e-commerce, agriculture products enterprises, they use data technology to achieve some precision marketing, which will effectively change the shortcomings of traditional marketing and improves the economic benefits here. So generally when compared to traditional marketing methods, right, first thing is accuracy. So general precision marketing activities are based on mining and they're analyzing consumer data. So they can ensure the accuracy of the marketing. So e-commerce enterprises can observe the changes of consumer preferences in real time and they can adjust the marketing plan under this precise and accurately push marketing messages related to the products for the users. So they have become an indispensable part of modern life. Consumer consumptions habits have gradually changed. So for instance, the agricultural products they have gradually become a hot part for online e-commerce platforms also. And we know that many other countries like they are good with agricultural production, like low urbanization, where you have the reasonable planting, production, sales of agricultural products can happen. So in terms of production, there has been a phenomenon of low purchase price of low planting of the flowers farmers because there is no good yield coming out. So e-commerce enterprises that implement precision marketing and can save marketing, advertisement costs, and transaction costs based on advertisers, and they can maximize the value of your marketing activities. So what it is going to happen is in order to improve the degree of marketization of any product, irrespective of agriculture or anything, you have to develop an agricultural product features trading. So which will in turn help the management departments of various industries so that they can streamline the process and understand things better and do more and more advertising so that it will reach to the maximum number of people. So media plays a very, very important role. Whatever the network you have built and who are people there in your network and how close you are there in the network, this is where you can find out and get very good improvement in this. So one such other example is that whenever you are doing a kind of um, marketing, right, you don't have to stick to only one particular platform here, right? The leverage here is that you are trying to predict the product of the sales to different ads which are being delivered on social media networking sites. So when a user on social networking site, after clicking the ads displayed on the website, they end up buying a product or not. This could be really helpful for the company for selling the product. So it's a car company which has paid some social networking website. So assume that it's a Facebook. So to display ads of its newly launched car. Now, since the company relies heavily on the success of its newly launched car, it will leave no one unturned while trying to advertise the car. So then, well, what is going to happen? What's better than advertising it on the most popular platform here? So it tries to know which platform I have to use. This could be in boosting the sales as well as in showing the ad of the car only to a selected crowd. And if you're showing to a selected crowd, what kind of crowd you would like to prefer? This is where you come in and the car company has hired you and they want to find out the correct crowd to which you need to advertise the car, and you want to find out the people who are most likely to buy the car based on certain features, purchased, not purchased, right? So you have which it will describe the type of the users who have bought the car previously, people who have clicked on the ad and they have purchased the car, people who have watched the ad and purchased the car. So you can be someone who has just completed the survey and you have collected the data and you can start processing it. So here we are discussing about the KNN algorithm, right, which is going to help us to find out who are the people who are similar to each other, so that you can target them, you can showcase your ad to them, so that what is going to happen is you will reach out to the maximum number of people who are of similar kind. Definitely sales are going to increase and finally your product would fly, right? So this is the application of classification algorithms and in media analytics. So here is how it is going to work. KNN, one of the whatever I have explained, it is not only used for classification, it is also used for regression also. So you have something which is called as KNN-C, KNN regression. If you want to predict numeric, also KNN helps you. The KNN working can be explained here like this. Suppose you have to select, you want to select 4 people or 5 people. I have clicked on the ad and I purchased. Who are the 5 other people who are similar to me? Right? So maybe the amount, the time spent is one factor. What I have here. Okay. And or you are a person. So what is happening? I will take the budget allocated for newspaper and the time spent means maybe the ad time. Let us just assume that it's an ad time. What is the budget? What is the time spent here? So like that you have continuous data or any number data you have it here. You are having various features to find out whether the person would likely to purchase that particular product or not. So here first k equal to 5 means what you are going to do. 2 categories are there. Let us say purchased A is purchased, B is not purchased. And a new person has come in here. And this new person is going to purchase or not purchase it. A is going to purchase or not purchase. So this is nothing but if you are saying k equal to 1, it will draw a boundary among itself, and what it does is it will try to pick up one friend of yours. Right? It will pick up one friend of yours, and that friend which color it is not purchased or it did not purchase, it will map that particular new data point to that particular class. So how it is going to calculate? If you have a person, right, 2 people, you want to give 1 nearest people. So from here to 1 nearest friend, it is going to map. From here, it is going to map to the one nearest friend. Okay, this one nearest friend belongs to which category? You will make him to that particular category. So if at all he has watched this particular click ad and he has purchased the product, right? Now if at all you want to find two people similar to you, that to the same, like he purchased on how many people you want to find? 5 people. So it makes a boundary here and it will pick up the 5 people, nearest people here for our this thing. So if at all you have now, if you see here, you have this is a boundary 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. So 6, k equal to 6, you have taken. If you see here, you have taken k equal to 3. Nearest people, you are taking that k is equal to 3. Right? If there is an ambiguity situation, what will you do? You focus on majority. You focus on majority. So for instance, now how we are trying to calculate the distance? The distance here calculated is okay. See, if at all the amount spent by a person on television for ad campaigning and time spent here is 9, he purchased the product on television. Okay, just assume that it is 9 seconds. Assume that it is the marketing is for dollars. Okay, so how do you do that now? This is different inputs I have taken. Instead of WhatsApp, we can take a YouTube also here. Okay, the amount for displaying or showcasing the ad you have paid for YouTube is 1 and the time spent is 10 seconds. Okay, or the time of the ad we can make it telecasting time, whatever, like that. Right, this is a telecasting time of the ad. So what is that we are going to get? If the amount you have spent in the telecasting time is this, he purchases a product. Via radio, amount spent is this, telecasting time is this. Okay, so newspaper, there is no time for that, right? So it is purchased. Here we can make it maybe 5, right? 10 seconds, 10 seconds, right? So he has purchased or he has not purchased. That is the output you have to find out. So when the time spent on Instagram, okay, the amount spent and the telecasting time is 4, whether a person would purchase or not purchase. Okay, you have to do. How you are going to do this? You are going to calculate the distance calculation. Distance calculation is nothing but 10, 9, 6, 4. So there is a formula to calculate this: x2 minus x1 whole square plus y2 minus y1 whole square. Okay, x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so how do you calculate that? This is my x1, this is my y1, this is my x2, this is my y2. Okay, so how do I calculate 10 minus 6 whole square plus 9 minus 4 whole square? Okay, 10 minus 6 whole square is a 4 square plus y square under root It is nothing but 16 plus 25, around 41. I think it should be 6.4. Some nominal numbers I have written here, not calculated clearly. So this is what we have done. So Euclidean distance is what I have calculated. Right? TV and Insta are matching, or radio and Insta strategy worked out. Newspaper or Insta is having good relationship. LinkedIn or Insta, or Facebook or Insta, YouTube or Insta. Which budget or which telecasting time is saying that now Instagram would similar to TV or radio or newspaper or LinkedIn or Facebook or YouTube. But comparing this with this other ad campaigns, you have calculated the distance and you have kept ready. Now KNN is nothing but it is the nearest neighbor. It is the nearest neighbor. The nearest neighbor. Okay, and this nearest neighbor is who is near to Insta, who is near to this. So that is decided with K. So K is equal to 1, right? Which is near to 1 now. Distance from this to this to this to this. So calculated. So because you are calculating distance, it is called as distance based algorithm. Okay. Now 6.4, what is this? 6.45, which is very, very smallest distance here, not purchased. So if you are doing an ad by spending this much amount or telecasting time, it did not work out for one particular ad. That ad which you want this thing. Now you are doing the same strategy with Insta. People did not purchase it. Okay, equal to 1. Okay, and K is equal to 2. If K is equal to 2, what is it you are doing here? Okay, equal to 2. Two nearest, smallest distances I want. 5, 5.8. So not purchased, purchased. Right, that time you go with shortest distance, which is smaller, not purchased. So not purchased. You go with shortest distance. K equal to 3. K equal to 3. 3 distances. 1, not purchased, purchased, purchased. 3. So if you go with the majority, most of the people purchased. It's classifying as purchase. Like that, you can increase your K equal to 4 with very small data sets, so they are not increasing much. K equal to 4, K equal to 5. You keep on increasing this K value, so which is going to help you in finding the strategy here. So, K, if you keep on increasing your like this, here the point is when you are doing your supervised learning algorithm, okay, you will train your model. You split your data into 2. One is a trained data and one is a test data. The split is in such a way that 80% of the data would come here, 20% of the data would come here. You hide this data because when you validate it, how can you validate it on unseen data? How it is going to work? You want to know on unseen data for a different ad. This is for one ad. For one ad, you are doing this. Right? 2 ads, 3 ads, different ads pertaining to different platforms. If at all you want to do, what is going to happen? You need to know which one is going to work the best. So you want to test on new data also. You don't have new data and you cannot validate it on the data which is available with us. You split the data into 80-20 ratio or 70-30 ratio. Okay, 80-20 ratio, right? So now if it is an ad pertaining to, like we have seen, a car, or it is a jewelry, or whether it is a health drink, or whether it is a any other product, right? So how many people, which particular product is getting highlighted and it is getting connected with more number of people is your aim to find out. So here, to know that we are dividing the data into two, 80 and 20%, and it is mandatory to do this. Okay, we will give training like this. Acha, if an ad is telecasted on TV with amount spent in telecasting spent, people purchased it. On radio, not purchased. And newspaper, they did not purchase. On LinkedIn, they did not purchase. So, like that, it is going to learn it here in the training phase. Okay, and when new data comes like this, given these details, it has to predict. When it predicts, okay, at what level it is going to predict correctly is done using accuracy, calculating the accuracy. Okay, suppose now this you are telling that this is purchased. Okay, but practically he did not purchase. Okay, he did not purchase. So what is happening here now? You want to know that your actual value, your predicted value are not matching, right? So you cannot subtract purchased minus not purchased. What is that? We cannot do any mathematical operation on categorical data. For that, you will evaluate it using something called as confusion matrix. Okay, you keep your actual value, you keep your predicted value. You say here purchased, not purchased, purchased, not purchased. Okay, purchased, not purchased, purchased, not purchased. How many of the values you have predicted as purchased and actual value also purchased? This also not purchased and not purchased. Okay, so these are the errors. Suppose actual value is not purchased, but predicted value is purchased. You have predicted as purchased, but it did not purchase. It is an error. Here also, actual value is purchased and predicted value is not purchased. It is an error. Actual value, predicted value. These two are your errors. To find out the error of your data, you add these two. Error 1 plus error 2 by total. Correct plus C1 plus C2 by total. This will give me accuracy. This will give me error. This will give me error. Okay. So this is how you calculate the accuracy of your model when you are working with classification models. Let us see the hands-on for this. So this is a data set and we are using sklearn package, and for splitting the data into 80-20%, we need train as split. So import pandas as 3D and numpy as np, and you are importing matplotlib as pyplot, and you are importing seaborn for visualization purpose, and you are using model underscore selection So modern school selection was prettier data. So sklearn is one such package where you have all the machine learning algorithms working here. So data is this data, it is a social network ads data. So it is user ID, gender, age, estimated salary, and they have purchased or not purchased. So here Karen algorithm is amongst the simplest of all the machine learning algorithms. The input consists of k closest training examples. So the output is a class and the object is classified by majority vote. So Kane and regressor, the output is a value. Okay. So now here it is having the information about the users on social networking site, using that information as features for our machine learning algorithm. So we try to predict that whether a particular user, after clicking an ad on social networking site, he is going to buy a product or not. The social network has a business client. Suppose now it's a car company. He advertises itself by putting ads on social networking website. Now the work of this network here is to gather information as to whether the user bought the product or not. So the dependent variable here is here purchased is 1, not purchased is 0. So we need to build a classifier which would put each user into a correct category by predicting who all purchased as purchased, who did not purchase as not purchased. So the important features here are data set is containing gender, age, user ID, estimated salary. So user ID has no effect whether the user would have purchased a car or not. Leave it. Gender, some might say that gender would play a role, but that is really very subjective for discussion. So since gender is a categorical variable, we would have to use a encoder, whether it is a label encoding or it is one hot encoding. Okay, so storing you can check with this data. Now if I do a describe function, here I can know I'll not get any gender output, but I get age, estimated salary, and purchased. And if you see here, the minimum value and the maximum value, minimum people who we have in our historic data is 15,000, and you have here 1,50,000 is the estimated salary highest. Okay, people purchased as 0 and 1. If you see this one, there are no null values in the data set. Okay, there are no null values in the data set. And if you see the spread of the data here, age which is continuous, it happens to be okay, kind of normal only. Even estimated salary is also okay here. If you see, most of them did not purchase, very few people purchased. Okay, and this is a plot here which is identifying the outliers. So it seems that there are no outliers in your data. Okay, I don't think so that we have user ID and gender are no way important for us. I'm dropping them. How am I dropping them? We have to drop using drop function. Axis is equal to 1, and you have to write axis is equal to 1 for column drop. And then you separate your x and your y. Okay, you are separating your x and your y. So df dot drop age, estimated salary, and purchased came into y. Now here if you see, I'm using train underscore test underscore split x comma y test size random set equal to 21. Okay, I just gave KNC initializing it, and I have given k equal to 21. If you see, the length is 400 rows into 2 columns. Out of 400 people, I would like to, when a new data comes in, compare, learn the pattern and map it properly. Okay, so I'm just saying I want to first give training. So for training, I have taken 70% of the data, and for testing, I have taken 30% of this. So this is a random split out of 1 to 400. Randomly, 80% of the data, 70% of the data would come to train, 30% of the data would go to test. So this line is I'm initializing k equal to 21. I'm fitting it on train and test split. Right now, knn dot predict. So this is my unseen data which I did not pass. This 30% of the data is not shown to training purpose. It's not exposed to algorithm. Okay, not exposed to this. So one more thing what you can do is you can do scaling also for this data. Why? Because you have age and salary being continuous. So scaling is also one method what you can give a try. You have to do scaling and then split your data. So now knn.predict, give only the input. This is what it has predicted. It's as simple as that. I'm giving training to students, giving 100 questions for exam. So what I thought, I'll take only 70 questions, 30 questions I'll hide from them. So these 70 questions, how did they prepare well? I will keep test on those 30 questions which I have hidden. So these are the marks what the student got for 30 questions here. Right? These are the 30 questions what they got. So what is happening? Here I should know the accuracy of this model, how well it has, how well you got the 30 for 30 questions, what are the marks you got. So what am I doing? From sklearn.metrics, you are importing accuracy underscore score. Okay, print accuracy score y-test spread. So now pd.crosstab y-test spread. Here, this is what you do as a cross tab, which is called as a confusion matrix, where it is giving you actual values and predicted values. 76 did not purchase, your model also is saying 76 did not purchase. 22 purchased, your model is also telling 22 was purchased. But actually they have purchased, your model is saying not purchased. Actually, one, they have purchased, but your model is saying they did not purchase. Here what is happening? Actually, they did not purchase, but your model is saying purchase. This is a dangerous scenario. 5. Okay, your aim is to reduce a dangerous scenario to less number. Why? Because actually they did not purchase, but your model is saying purchase. So you feel that your model is very, very good, and you take that mode of advertisement and you will give them personalized offer or something like that, so that you connect with them and you try to get in touch with them. You will get to know that he is not interested, he get irritated. So customer service satisfaction is very, very important here, and you should not get bad review that these people are calling us and irritating us for their purchasing of the particular product. So your aim is to reduce this particular 5. So what is that you are going to do now? So here pred underscore train is equal to knn dot predict x underscore train. Okay, and this is you are predicting on train data. It means that you are cross checking not only on your test data, but first you check on your 70 questions what you have given. First 70 questions what they have given, let us check, then we'll check on 30 questions, so that you'll understand how nicely they have prepared these 70 questions. So that is your X train. So you have given 70 questions. You are asking them to write exam on 70 questions. You have hidden 30 questions. You did not give any training. You kept the exam so that you evaluate them so that they are ready to write the exam or not. If you see here, 12 are your errors. 164, 60, 44 is not a big problem, but here 12 is a problem. Actually, he did not purchase, but the model is saying he purchased 12 number is there, and your aim is to reduce this 12 number. So this is called as to reduce few things. You have to go for tuning parameters. Every algorithm has one tuning parameter. Every algorithm has a tuning parameter which is called as hyperparameters. So it is nothing but you take k. Okay, you take k. K is a tuning parameter here. So k equal to 1, k equal to 2, k equal to 3, 4. You can take any number of values of k and check your this number is coming down or not. So for that, what I can do, I'll write a for loop. I'll write a for loop. What is this for loop now? I would range in k equal to, it will start with k equal to 3, k equal to 50 with a difference of 2, like this. So preferably people say that choose odd value of k because there will be no ambiguity situation. Like, purchased, not purchased, both are coming. Where you have to dump the new data. You want to dump the new data to purchased or not purchased. So generally we don't prefer k being a even value, only prefer k being an odd value. Like that, so you have taken 2, 2, 2, 2 till 50. Take each value, build your model, fit your model, get the accuracy on train data, get the accuracy on the test data. Once you get that accuracy, you just append them to this. Okay, append them to this empty list variable, whatever you have created. So I'm running it for how many different range values of this. If you observe, you got this many models I have built. This is called as tuning your parameter, and this tuned parameter gave us different accuracies. These gave you different accuracies. It means that you want 0.8 or you want to increase the accuracy. The only weapon you have in your hands is K. Okay. The only weapon you have, you can do changes this. So to observe this, what we are doing, we want to pick up, maybe there's a chance that you want k equal 21 is not the correct choice and you want to go and rerun the model. For that, see here, this is, you have it means that if you're not writing this loop like this, you're coming here, putting this is equal to 3, running it, fitting it, predicting it, checking the accuracy, again going back, putting k equal to 3, 4 and building the model, testing it. So to solve this, we have written a for loop. So these are the accuracies. This is my train accuracy. This is my test accuracy. There are few instances to be observed here. If your k value is increasing, so what did I do now? This is my data. I splitted it like this, which is train, this is test. I gave training on this and I predicted on this. So I can also predict on this, which will give me train accuracy. I can predict this, I get text accuracy. If these two are going hand in hand, this is called as, you can close your eyes and move forward and go for deployment. It is called as right fit. Okay, but If your train accuracy increases and your test accuracy is less, this is called as overfitting. If your train accuracy is less, test accuracy is also less, then you say that it is underfitting. So you have to choose which value of k is giving you nearly train and test accuracy equal, the good accuracy point, or both are nearly equal. 1 to 2% difference is what you can accept, but not more than that. 2 to 3% is what you aim for. So now I can't sit and do all this checking. So I'll do a plot here. What is a plot I do? I'm saying import matplotlib.pylab as a plt. Okay, plt.plot. Here, this is going to give us k. You are arranging your k values on your x-axis. These are the accuracies on your y-axis. Okay, so you are arranging it 3, 5, 10, all that. This is saved in I of 0th location. This is I of 1th location. Okay, you take star red color hyphen. Okay, and you take B O minus. So this is my train accuracy. This is my test accuracy. If you see here, there is a huge difference between these two for very less value of k. Right? See, this is what a situation. You want where the difference between both of them should be apt. Maybe something in between these two. So k, this is training, this is testing. If this difference is very high, then this is k equal to 30, suppose. Your model is overfitting. Your model is overfitting. If both are nearly equal, then we can say that your model is a right fit. So we cannot go and choose some random value of k here. So what you have to do is, you have to do a for loop and pick up the right value of k, go back and do the deployment part. Here there is no separate training phase here. So it is not going to learn anything. It takes the data and does the calculations. This is called as distance based algorithm, and it may not do any much math calculations or patterning. It's just calculating the distance. So it is called as a lazy learner. Okay, it is called as the lazy learner. Okay, so this algorithm is the first classifier what we have understood. So we have seen that in data mining, we have divided it into supervised, unsupervised. In supervised, you are divided into regression classification. In this, we are studying two, which is KNN, and tomorrow's session will be decision tree classifier. Here we have covered K means clusters being formed. Okay, so these are the applications of KNN here. So we end our predictions, right? We can also do a nice visualization here with respect to your accuracies, so that it is going to help you to know how well your model is able to predict. And one more thing we can add here is we can do scaling on the data and try accordingly. So that's it. Here the conclusion. So it makes predictions on fly by averaging the similarity between the input and the output. So that's why it's called as lazy learner. So thank you all for joining in. That's it, KNN classifier. Thank you.